This is a note about trig ratios. There is an acronym you might be familiar with, SOHCAHTOA, for remembering definition of sine, cosine and tangent functions. And the phonetics come from SAW, standing for sine is equal to O upon H, which you can pronounce as SAW as a summary. Ka, meaning we're standing for cosine, being defined as the adjacent side divided by hypotenuse, and TOA, tangent, being defined as O, the opposite side divided by the adjacent side, where opposite, adjacent and hypotenuse refer to the right angle triangle. And if we label our angle of interest as B, then we see that sine B is equal to O upon H, cos B is equal to A upon H, and tan B is equal to O upon A. Some useful results. Sine squared B plus cos squared B is therefore equal to O upon H all squared plus A upon H all squared, which is equal to O squared upon H squared plus A squared upon H squared. And when we have a common denominator, we can just add the numerators. O squared plus A squared. By Pythagoras, O squared plus A squared is equal to H squared. And so sine squared plus cos squared is equal to 1. Other things that are useful to note from this triangle are that, well, as it's drawn here, B is quite a small angle, and we can imagine if B got closer and closer to 0, then the opposite side of the triangle to the angle of interest would become smaller and smaller until eventually it got to 0. And so we can say that the sine of 0, or we can infer that the sine of 0 as in 0 degrees would be equal to the ratio O upon H, where O approaches 0, and so we end up with 0 upon H, which becomes 0. By the same token, if B approaches 90 degrees, then the cosine ratio, or the sine ratio for 90 degrees again would be O upon H, but in this case O would approach the same length as H, and eventually when we reach 90 degrees, sine of 90 degrees becomes effectively H upon H, which becomes 1. And it's often useful to know quickly, or if you've forgotten, what the value of sine 0 is and what the value of sine 90 is. By the same token, cosine of 0 degrees we could deduce from the triangle as it's drawn. Again, looking at B being very small, then the cosine is A upon H. As B gets to 0, A and H become the same length, and the cosine ratio A upon H becomes 1. And we can also then deduce that the cosine of 90 degrees is where A becomes very small compared to H, and eventually at 90 degrees A is 0, and 0 divided by H is 0, so cosine of 90 degrees is 0. So it's just a way of remembering that if it escapes you.